video, I'm going to talk about dividing polynomials. But before we talk about dividing polynomials, we're going to talk about how we can name polynomials. There are two different ways to name a polynomial. One of those ways is to name it by its degree, or its highest power. The second way to name a polynomial is by the number of terms that it has. So if we look at the first example, y is equal to 6, if we wanted to name that by its degree, its highest power, it doesn't have an x value. So we say that's the 0th degree, since it doesn't have x to any power. And we also call it a constant. So if it's a 0th degree function, it's a constant. If we were to name it by the number of terms that it has one term. So we call it a monomial, because mono means one. So we call it a monomial. If I have y is equal to 2x plus 3, and I wanted to name that by degree, I'm looking at what's the highest x power. And I have x to the first power there. So this is a first degree function. And we call that a linear function, because it's going to look like a line. And we know that. It's y equals mx plus b form. If I name it by the number of terms that it has two terms. So I know this is a binomial. Bi means two, binomial. If I'm looking at the third function that I have there, y is equal to negative x squared. Oh, this should be plus, not equal. 5x minus 8. I know I'm looking for the highest degree, and that is the second degree. So this is a second degree function, and I call this a quadratic. We've talked about this a lot. A quadratic function, because it's going to look like a parabola. If I name it by the number of terms that it has 3 terms, so I call this a trinomial. Tri means 3. Trinomial. If I look at the fourth function, I have 5x cubed plus 2x minus x minus 8. When I'm looking to name it by the degree, I'm only looking at the highest degree that I have. And the highest degree that I have is 3. So this is a third degree function. And we call that a cubic function. A cubic function. To name it by the number of terms that it has 4 terms. If something has 4 or more terms, we just call it a polynomial. A polynomial. Poly means multiple. And we specify it's a polynomial with 4 terms. That's how we name it by the number of terms. For the next one, I have the highest power is 4. So I know this is 4th degree. And I call that a quartic function. And if I name it by the number of terms that it has 3 terms, so I call it a trinomial. And then the last one there, it's 5 terms, so it's more than 4. I call it a polynomial with 5 terms. And if I name it by its degree, the highest degree that I see there is 5. So it's the 5th degree. It's a 5th degree function. And we call that a quintic function. All right, now, before we go into division with polynomials, I want to remind us how we do long division with regular constants, with just regular numbers. 25 divided by 5. Well, do we even need long division for that? No. But if we were to use long division for that, I would ask myself, how many times does 5 go into 2? And I would say 0 times, and I'd put a 0 on top. And then I would say, well, how many times does 5 go into 25? And then I know that it's 5. 5 times 5 is 25. I subtract that, and I get a remainder of 0, so I know the answer is 5. This number that's on top. If I divide 228 divided by 4, I'm putting 228 inside of my long division bar. And then on the outside, I'm putting 4. I'm asking myself, how many times does 4 go into 2? And I know that it doesn't fit into 2, so I put 0 on top of that 2. Then I ask myself, well, then how many times does 4 go into 22? And 4 goes into 22 5 times, so I put a 5 on top. Then I multiply 4 times 5 to get 20, and I subtract that from 22 to see that I have a remainder of 2. I bring down the 8, and then I ask myself, how many times does 4 fit into 28? Well, 4 fits into 28 7 times. And then I know 4 times 7 gives me 28. So I have a remainder of 0 once I do that. And then the answer is 57. For this next one, I have 1,728 divided by 12. And I'm asking myself, how many times does 12 fit into 1? 0 times. So then I go to 17. How many times does 12 fit into 17? It fits in 1 time. I'm going to subtract 12, and that's going to give me a remainder of 5. I bring down the next number, the 2. I ask myself, how many times does 12 fit into 52? And 12 fits into 52 4 times. 12 times 4 gives me 48. I'm going to subtract 48, and that gives me a remainder of 4. Then I ask myself, I have to bring down that 8. I ask myself, how many times does 12 fit into 48? It's 4 times. I multiply 12 times 4 to get 48. I subtract that, and I'm left with a remainder of 0. So I know this fits in perfectly. My answer is 144. And then for the last one, I have 755 divided by 3. I'm asking myself, how many times does 3 fit into 7? And it's 2 times. 3 times 2 gives me 6. I subtract 6 from 7, I get 1. And then I bring down 5. 3 into 15 is 5. I multiply 3 times 5 to get 15. And I'm left with a remainder of 0. I bring down the 5. 3 fits into 5 1 time. 3 times 1 is 3. I have a remainder of 2. And I'm going to write this answer as 251 with a remainder of 2. So I'm going to have to divide 2 by 3. I have 251 and 2/3. And that's how you do long division with numbers. It's the same exact thing with polynomials. So the way that I start, I put the polynomial I'm dividing inside of the long division bars. Long division bar? I don't really know what that thing is called. So 5x cubed plus 3x squared minus 4x minus 4. I'm dividing by x minus 1, so that goes in the outside. I'm asking myself, how many times do I have to multiply? I'm just looking at the first term, the x. How many times do I have to multiply x, or what do I have to multiply x by to get 5x cubed? And the answer is 5x squared. So I have to multiply by 5x squared. Then I want to multiply x minus 1 times 5x squared. I need to distribute that 5x squared to both the x and to the minus 1 when I multiply. So when I multiply x times 5x squared, I get 5x cubed, which is what I wanted because I want to be able to cancel out. I want to be able to get rid of that 5x cubed. And then I multiply negative 1 times 5x squared, which gives me negative 5x squared. And now, just like I did in all of these examples, I'm going to subtract. I'm going to subtract what I got when I multiplied x minus 1 times 5x squared. And when I subtract, I cancel out 5x cubed. That goes away. I'm left with 3x squared minus negative 5x squared, which gives me 3x squared plus 5x squared, which is 8x squared. I bring down the minus 4x, and then I do it again. So I ask myself, how many times does x minus 1 fit into 8x squared minus 4x? And I'm only concerned about what do I have to multiply x by to get 8x squared. And the thing I have to multiply it by is by 8x. And if I multiply by 8x, or x by 8x, I'm going to get 8x squared. And if I multiply negative 1 times 8x, I'm going to get negative 8x. And I'm going to subtract this and see what I have left to take care of. So I'm subtracting. I get 8x squared minus 8x squared is 0. And then I have negative 4x minus negative 8x. So that's negative 4x plus 8x, which gives me 4x. I bring down this minus 4. I ask myself, how many times does x minus 1 fit into 4x minus 4? And it should be clear to you that that is 4 times. So I'm going to add 4 on top here. 4 times x gives me 4x. 4 times negative 1 gives me negative 4. I'm going to subtract this. If I have a remainder of 0, that means x minus 1 fits in perfectly. It is a factor of this thing inside. And my answer is just that number on, or that expression on top. So 5x squared plus 8x plus 4 is my answer. All right, I want you to pause the video and I want you to try this example on your own. All right, for this example, inside of the long division bar, you put x cubed plus x squared minus 11x plus 10. You're dividing by x minus 2. So you're asking yourself first, how many times does x minus 2 fit into this thing? And what you want to do is ask yourself, what do I have to multiply x by to get x cubed? And that is x squared. So x times x squared gives me x cubed. And then I also have to distribute that x squared to both of these terms. So to the negative 2. I multiply negative 2 times x squared, which gives me negative 2x squared. And this is what I'm subtracting to see what I have left over to take care of. And when I subtract, I'm going to end up with x squared minus negative 2x squared, which is x squared plus 2x squared, which is 3x squared. I bring down the negative 11x. I'm asking myself now, what do I have to multiply x by to get 3x squared? And I have to multiply x by 3x to get 3x squared. I'm going to distribute that 3x to both terms when I multiply, so 3x times x is 3x squared. 3x times negative 2 is negative 6x. I am subtracting that to see what I have left over. And that's going to be negative 11x minus negative 6x, which is negative 11x plus 6x, or negative 5x. I bring down that last number. I'm going to ask myself, how many times do I have to multiply x to get, or how many times does x minus 2 fit into negative 5x plus 10? And the answer is minus 5 times, or that's what I have to multiply x minus 2 by to get negative 5x plus 10. And just to check, negative 5 times x gives me negative 5x. Negative 5 times negative 2 is plus 10. I'm subtracting this to see what I have left over to take care of, and I have nothing left over. So the answer is just that expression on top, x squared plus 3x minus 5. Okay, and then I want to also, so that's long division. If you do it like that, it's called long division. You can also divide polynomials using something called synthetic division. And this is a shortcut to what we just did up here. So if I wanted to divide 3x squared minus 2x plus 5 divided by x plus 1, I would put inside of the synthetic division bar, I would put the coefficients for the polynomial that I am dividing. So 3, I would put negative 2, and I would put 5 in the order from highest power to lowest power. And you need to include every power if you use this shortcut, or you will get the wrong answer. So I have every power from x squared down to my constant. So I have x squared, x to the first power, and x and no x. So inside of the synthetic division bar, I put 3, negative 2, and 5. And then on the outside, I'm going to put whatever x is to make that factor equal to 0. So I want x plus 1 to be equal to 0. I'm going to solve for x by itself. What does x have to be? It should very obviously be 2u negative 1. X should be negative 1. That is the number that I'm going to put on the outside. First thing I'm going to do is I'm going to bring down this 3. I'm going to bring down that 3. Then I'm going to multiply -1 times 3, and that's going to be what I put here. So -1 times 3 gives me -3. Now I'm going to add these two numbers together. And when I add them together, I'm going to end up with -5 on the bottom. Then I'm going to do the same thing. I'm going to multiply -1 times -5. And that's going to give me 5. I'm going to put that number here. So that number goes here. Now I'm going to add 5 plus 5, which gives me 10. And I'm finished, almost. I just have to use these numbers as my new coefficients. So this number on the right is always going to be what my remainder is. That's always going to be the remainder. This number here is always going to be the next number to the left is always going to be your x term. Your x to the, it's going to be your constant. The number to the left of that is going to be your x to the first power. And then if you had more numbers, it would be x squared and x cubed to the left of that. But I only have x to the first power and my constant. So this is the coefficient for x. So I really have 3x, and this is just the constant. So -5 plus a remainder of 10. So I have a remainder of 10, which means I still have to divide 10 by x plus 1. And this is my answer. For this one here, if I wanted to do this one, I would, first things first, I need every power from the highest power down to the constant. I need to include every single one in order to use synthetic division. So really what I have here is x cubed minus x squared plus 0x minus 48. And that's what I'm going to be dividing. So let me actually move this over so we can see this better. So I'm going to move this over to here. And that way I can write right underneath. So the coefficient for x cubed is 1. The coefficient for x squared is -1. The coefficient for x is 0, and then my constant is -48. And those are the numbers I'm going to put inside the synthetic division bar. So I have 1, -1, 0, and -48. And then the number that's going to go on the outside is whatever makes this 0. So whatever makes x minus 4 0, that x value. So x minus 4 is equal to 0. Solve for x. I know x is 4. That's what I'm going to put here. And then the first thing I'm going to do is bring down that 1. Then I'm multiplying 4 times 1, which gives me 4. Then I do -1 plus 4 gives me 3. Then I do 4 times 3 gives me 12. Then I do 0 plus 12, which gives me 12. And then I do 4 times 12, which gives me 48. Then I do -48 plus 48, which gives me 0. This is my remainder, so I don't have a remainder. This is my constant. I always mess that up. Constant. The one to the left of that is my x term, and the one to the left of that is x squared, my x squared coefficient. And so I have, my final answer is x squared plus 3x plus 12, and that's my final answer. All right, and then going down here, I have 2x cubed minus 3x squared minus x plus 1. That means the coefficients that I am using inside of my synthetic division bar is 2, -3. I have -1, since I have all the powers from x cubed down to the constant. And then I have plus 1 is my constant. That goes here. Then I know the number on the outside is whatever makes this equal to 0. So it's 2x minus 1 is equal to 0. I add 1 on both sides. I get 2x is equal to 1. I'm going to divide by 2. I know x is 1/2. So my 0 is 1/2, and that's the thing that's going to go on the outside. And I bring down the 2 to start. I multiply 1/2 times 2, which gives me 1. -3 plus 1 is -2. 1/2 times negative 2 is negative 1. Negative 1 plus negative 1 is negative 2. I multiply 1/2 times negative 2, which is negative 1. And then 1 plus negative 1 gives me 0. So 0 is my remainder. The number to the left of that is my constant. The number to the left of that is x to the first power. And the number to the left of that is x to the second power, the coefficient for those terms. And then I have my final answer is 2x squared minus 2x minus 2 with no remainder. Okay, and then trying this one here. My coefficients are 2. I have 3. I have all the powers included from x cubed down. Negative 6 and 5. And then on the outside, I put what makes this 0, so that's negative 3. I bring down the 2. Negative 3 times 2 is negative 6. This is negative 3. Negative 3 times negative 3 is 9. This will be negative 3 when I add them. Oh, sorry. Nope. It will be positive 3 when I add them. And then I have negative 3 times 3, which gives me negative 9. I have a remainder of negative 4. So this is my remainder. This is my c. This is my x to the first power coefficient. And this is my coefficient for x squared. So my final answer is 2x squared minus 3x plus 3. And then I have a remainder of 4, so I do minus 4. And you're still going to have to divide 4 by x plus 3. So you put it over x plus 3. And this is the answer. The reason why we're learning how to divide polynomials is so that we can factor something that looks like this, because we don't know how to factor that thing based on the factoring that we talked about previous to this. So if I tell you, here is a function, it's divisible by this factor, you can divide to factor this thing and see what other factor it has. I'm going to use synthetic division for this because it's easier. I'm going to take the coefficients. So for x cubed, it's 1. For x squared, it's 1. For x, it's negative 9. And for what my constant is also negative 9. And then the number that's going to go on the outside is what makes this 0. So that's negative 3. I bring down the 1. I have negative 3 times 1, which gives me negative 3. 1 plus negative 3 is negative 2. Negative 3 times negative 2 is 6. Negative 9 plus 6 is negative 3. Negative 3 times negative 3 is 9, and then I get 0. The reason we use synthetic division instead of writing everything out is because what we're doing when we do long division is we're just focusing in on what the coefficients are, right? So this is just getting rid of the extra stuff, the extra x's and x squareds and x cubes. So we'll look at an example and we'll compare synthetic division to long division later so you can see what it means. But for right now, I just wanted you to learn that shortcut. And now I know that this is the remainder, this is the constant, this is the coefficient for my x term, and this is the coefficient for my x squared term. So I can rewrite this as y is equal to, I know this is a factor, x plus 3, and then the other factor is x squared minus 2x minus 3. I can factor this thing further because I know how to do that when it's ax squared plus bx plus c form, and I can find two numbers that multiply to negative 3 and add up to negative 2. Those two numbers are negative 3 and 1. So this breaks down into x minus 3 times x plus 1 since a is equal to 1 there. I have now x plus 3 times x minus 3 times x plus 1. And I can find all my important information that I can graph or use to graph this thing. So the important info to graph this thing. First thing I always start with is my x-intercepts. So what are my x-intercepts here? I have from here negative 3, from here positive 3, and from here negative 1. What are the other thing I can find very easy is my y-intercept. That's another important point I'm going to plot. The y-intercept is this when x is equal to 0. So I have y is equal to 3, if I use the factored form, times negative 3 times 1. And that gives me negative 9. So I'm going to graph all those important points. 2, 3, 2, 3, and then I'm just going to label -9 here. All right, so -9 is my y-intercept. My x-intercepts are -3, +3, and -1. And the other important information that I need is the end behavior. So what's the end behavior going to look like? And how I'm going to find the end behavior is by looking at what's the highest power. So in my standard form, the highest power is x cubed, and I know how I have a positive coefficient for that. So my end behavior is going to look like this. As I put in bigger and bigger negative values, I'm going to get out smaller and smaller numbers, or so I'll be decreasing, right? The bigger the negative that I put in, because when you cube something, it keeps the sign. So I'll be going downwards to the left and then upwards to the right. Since I have an odd power, I go in opposite directions. And as I put in bigger and bigger positive values, I'm going to get out bigger and bigger positive numbers when I cube something. And so I know that from my leftmost point, I'll be going downwards to the left. And from my rightmost point, I'll be going upwards to the right. And then I use what I know about my x-intercepts. If there's any multiple zeros, I would change direction, but there aren't, so I should be going straight through each one of these points. So I'm going straight through. Since I was going upwards to get to that x-intercept, I'm going to continue upwards. At some point, I need to change direction to get back to the next x-intercept. Then I have to go straight through that one, down through my y-intercept. At some point, I need to turn around to get back to the last x-intercept, and I should be continuing through, not changing direction. So that's what it looks like. I want you to pause this video and try this example here. All right, for this example, if you use synthetic division, you could have also used long division for this, but I'm going to do it with synthetic division. I have my coefficients. I have all powers from x cubed down to the constant, so I'm going to use my coefficients. 1 for x cubed, 2 for x squared. I have -13 for x, and 10 for my constant. The number that's going to go on the outside is what makes this 0, so that's 1. I'm going to bring down the 1. I have 1 times 1 gives me 1. 2 plus 1 is 3. 1 times 3 is 3. -13 plus 3 is -10. I have 1 times -10 is -10, and this gives me 0. So this is my remainder. Going to the left, I have this is my constant, this is my x to the first power coefficient, and this is my x squared coefficient. So I am going to have x squared plus 3x plus, minus 10 times x minus 1. And that's my, I'm factoring this thing. I want to factor it further. This thing breaks down if I use the diamond. I can find two numbers that multiply to -10 and add up to 3. And those two numbers are 5 and -2. And then I can break this down into x plus 5 times x minus 2 times x minus 1. And then I use that factored form to find all my important information. So the important info of this, starting with my x-intercepts, I want my x-intercepts, my y-intercepts. Those are my important points. So the x-intercepts, from here, I have -5. From here, I have 2. From here, I have 1, because I want y to be equal to 0, and when will y be equal to 0? When one of these three factors is 0. So I'm looking for when these things will be, what x values will make them 0. Then my y-intercept is going to be what I would get when I plug in x is equal to 0. So that's y is equal to, if I use my factored form, 5, so 0 plus 5 is 5, times -2 times -1, which gives me -10 times -1, which is +10. And that's 0, 10 is my, my y-intercept. And then to graph my other points, my x-intercepts, -5, 2, and 1. I'm going to use the last thing I have to find is my end behavior. So end behavior is going to be y is equal to x cubed again, because it's positive and the highest power is x cubed. That's what it's going to model, the end behavior, and I know that's downwards to the left and upwards to the right. Positive leading coefficient and an odd power, so that's what it looks like. So to the left, I look at the leftmost point, I should be going downwards to the left of that, and I look at the rightmost point, and it should be going upwards from there. Every point I'm going straight through because I don't have a multiplicity of anything for any of these x-intercepts, so I'm going straight through this point. Eventually I got to turn around to get to the next x-intercept. I got to go straight through that. Eventually I have to turn around to get to the next x-intercept, and I can continue straight through to that because it's not a multiple zero.